Hello everyone, welcome to today's lecture. In today's lecture, we will see some practice questions based on definite integrals. In the last lecture, we had completed the theory portion of definite integrals. Right, so in this lecture, we will cover from question number 1 to question number 6. The images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. Let's start with question number 1. Question number 1 says that we have to find integration from pi by 4 to 3 pi by 4 dx upon 1 plus cos x is equal to. So the hint of this question is you can see we have to apply dx upon 1 plus cos x. You can use that formula. You can replace cos x as 1 minus 10 square x by 2 upon 1 plus 10 square x by 2 like that. Or this was the basic method of indefinite integrals. Or you can apply the formula. You can apply the formula integration of 0 to a fx is equal to integration of 0 to a f of a minus x. That is, if from a to b, if integration is from a to b, then integration from a to b fx is equal to integration from a to b f of a plus b minus x dx, right? So you can use these things to solve this question. You have 10 seconds to solve and think about this question. After 10 seconds, we will discuss the solution. Okay, let's move to the solution part C. As we can see, I is basically from pi by 4 to 3 pi by 4 dx upon 1 plus cos x. Right. Now see, we can use that two method also, but see, if we multiply and divide by 1 minus cos x, if we can multiply and divide this expression by 1 minus cos x, then you will get pi by 4 to 3 pi by 4 1 minus cos x upon 1 minus cos square x dx. Clear? Then see, 1 minus cos square x can be written as sin square x, right? Therefore pi by 4 to 3 pi by 4 1 minus cos x dx upon sin square x is equal to integration of pi by 4 to 3 by 4 1 by sin square x will be cosec square x minus cos x upon sin square x is basically cosec x cot x dx. Clear? Therefore integration of cosec square x dx can be written as minus of cot x plus integration of minus cosec x cot x dx is basically cosec x. And limit of integration from pi by 4 to 3 pi by 4, then we can write see, when you will put the limit 3 pi by 4, you will get 1 plus root 2 minus when you will put the limit pi by 4, then you will get the answer as minus 1 plus root 2. After solving this, you will get answer as 2, which is option B. And B is the right choice. Fine. Option B is the right choice. Okay, let's move to the next question. Question number 2, which says, if fx is a continuous function, then which of the following options are correct? So the hint of this question is option A says that minus 2 to 2 fx dx is equal to 0 to 2 fx minus f of minus x dx, like that. So the hint is you have to analyze each option separately, right? And see whether and you have to see whether these options are following properties of definite integration or not. If any option is following property of definite integration, then that will be the correct answer, right? Okay, so you have 10 seconds to solve and think about this question. After 10 seconds, we will discuss the solution. Okay, let's move to the solution part C. Since fx is a continuous function, therefore let x is equal to t minus 1, right? X is equal to t minus 1. Therefore, why we have assumed x as t minus 1? Because see, in function, you can see that fx and f of x minus 1. That's why I have assumed x as t minus 1. Therefore, dx will be equal to dt, right? When x tends to minus 3 and 5, then t tends to minus 2 to 6, right? Because x is equal to t minus 1. Therefore, integration of minus 3 to 5 fx dx is equal to integration of minus 2 to 6 f of t minus 1 dt, right, which is equal to integration of minus 2 to 6 f of x minus 1 dx. Clear? Therefore, answer will be D option, which is integration from minus 3 to 5 fx dx will be equal to integration of minus 2 to 6 f of x minus 1 dx, right? So option D is the right choice. Option D is the right choice. Got it? Let's move to the next question, question number 3, which says that you have to find integration of 0 to pi by 4 root of 10x plus root of cot x dx is equal to. So again, the hint of this question is, see, what you can do by observing this question, you can write root cot x as 1 by root 10x. One thing you can do this. Also you can see integration is from 0 to pi by 4. You can apply the formula of like integration of a to b fx. Integration of a to b fx dx can be written as integration of a to b f of a plus b minus x dx, like that, right? So these things you can apply. Okay, and if you have another some more things in mind, you can also apply, right? Fine. So you have 10 seconds to solve this question. After 10 seconds, we will discuss the solution. Okay, let's move to the solution part C. As let I as 0 to pi by 4 root of 10x plus root of cot x dx. Now see, you can write cot x as 1 by 10x, or you can convert 10x and cot x into sin x and cos x, right? Therefore, let's convert 10x. Let's write 10x as sin of x upon cos x, and cos x as cos x upon sin x. Therefore, I is equal to integration from 0 to pi by 4 sin x plus cos x upon root over sin x into cos x dx. Clear? Now, see, you can convert sin x plus sin x into cos x into this form as root 2 into 0 to pi by 4 sin x plus cos x upon. What we have done, we have basically multiplied and divided by 2. By root 2, right? So root 2 will be multiplied and root 2 will be divided. So this divided root 2 will go inside this, which is equal to C, which is equal to root of 2 sin x cos x, which can be written as root of 1 minus sin x minus cos x whole square, right? Now let's put sin x minus cos x is equal to t. Therefore, cos x plus sin x dx will be equal to dt, right? Therefore, I is equal to root 2 into. See, if x is 0, then t will be C. If x is 0, then what will be t? T will be 0 minus 1. Then t will be minus 1. And if x is pi by 4, then t will be 0. Therefore, I is equal to root 2 minus 1 to 0 dt upon root over 1 minus t square, right? Therefore, I is equal to root 2 into sin inverse t minus 1 to 0. Clear? Therefore, I is equal to root 2 into, let's put limit from 0 to minus 1. Then you will get I equal to root 2 into 0 minus pi by 2, which is equal to pi by root 2. Clear? Option C is the right choice. Option C is the right choice. Got it? Let's move to the next question, question number 4, which says that you have to find integration of 0 to 1 sine of 2 tan inverse root over 1 plus x upon 1 minus x dx. Clear? Is equal to C. The hint of this question is you have to do some substitution. When you usually see these types of questions in which tan inverse something that can be substituted, right? So you can easily substitute x as something which we will discuss when we will discuss the solution, right? So you just have to think the basic substitution of, or you have any another thing in mind that further simplifies this integration to make it in integrable form. You can also apply that, right? So you have 10 seconds to solve or think about this question. After 10 seconds, we will discuss the solution. Okay, let's move to the solution part C. We can write 0 to 1 sine 2 tan inverse root over 1 plus x upon 1 minus x dx. Now, as we have discussed, let's put x equal to cos theta. X equal to cos theta. Therefore, it can be further written as sine of 2 tan inverse root over 1 plus cos theta upon 1 minus cos theta. Therefore, it can be written as sine 2 tan inverse root over 1 plus cos theta upon 1 minus cos theta can be written as cot of theta by 2, cot of theta by 2, right? Because 1 plus cos theta can be converted in terms of cos square theta, and 1 minus cos theta can be converted in terms of sin square theta, right? Therefore, it can be further written as sine of 2 tan inverse cot theta by 2, which is equal to sine of 2 tan inverse tan pi by 2 minus theta by 2, right? Sine of 2 tan inverse, because cot theta by 2 can be written as tan theta by 2 tan pi by 2 minus theta by 2, right? So it can be further simplified as sine of 2 tan inverse tan theta can be written as, because tan inverse tan of any angle theta, tan inverse tan theta is basically theta, right? Therefore, it can be written as sine of 2 into pi by 2 minus theta by 2, which can be written as sine pi minus theta, which is equal to sine theta. Now, which can be equal to root over sine theta. Sine theta can be written as root over 1 minus cos square theta. And we have made a substitution by putting x is equal to cos theta. Therefore, 1 minus root over 1 minus cos square theta can be written as equal to root over 1 minus x square, right? Therefore, integration from 0 to 1 sine of 2 tan inverse root of 1 plus x upon 1 minus x dx is finally written as integration of 0 to 1 root over 1 minus x square dx. Clear? Now, you can apply integration by parts. Clear? You can easily apply integration by parts to write one integration by parts, or we have discussed the formula to integrate root over a square minus x square, right? Clear? And that formula was also derived by the use of integration by parts, right? So you just had to remember the formula, and we will apply that formula here, right? And by using that formula, the answer will be 1 by 2x root over 1 minus x square, and limit is from 0 to 1, plus 1 by 2 sine inverse x, and limit is from 0 to 1. And after putting the limit 1 and 0, you will get answer as pi by 4. Clear? So option B is the right choice, pi by 4. Option B, pi by 4 is the right choice. Fine. Let's move to the next question, question of 5, which says that if I1n is equal to 0 to pi by 2 sine 2n minus 1 upon sine x dx, and I2n is equal to 0 to pi by 2 sine square nx upon sine square x dx, and belongs to n, then which option is right? See, what you have to do, the hint of this question is, see, I2n is here. You have to first find I2n plus 1, right? I2n plus 1. How will you find I2n plus 1? You will replace n with n plus 1, right? And further, simplify I2n plus 1. You will simplify I2n plus 1, and you will get the result in terms of I2n plus 1, I2n, and I1n, right? I1n. And I1n is given, right? So in this way, you can approach this question. You have 10 seconds to solve or think about this question. After 10 seconds, we will discuss the solution. Okay, let's move to the solution part. See, what will we first? Let's find I2n minus I2n minus 1, right? We can also find I2n plus 1 minus I2n, right? But we are calculating I2n minus I2n minus 1, which is equal to integration of 0 to pi by 2 sine square nx minus sine square n minus 1x, sine square nx minus sine square n minus 1x upon sine square x dx. Now, see, this formula you have to remember. Sine square a minus sine square b is equal to sine of a plus b into sine of a minus b, right? You have to remember this. Clear? Clear? So sine square a minus sine square b is basically sine a plus b into sine a minus b. Therefore, it can be further simplified as sine square nx minus sine square n minus 1 x. It can be written as sine of 2n minus 1x into sine x upon, in the denominator, it is written as sine square x into dx. Therefore, it is equal to 0 to pi by 2 sine of 2n minus 1x upon sine x, because 1 sine x will be cancelled out with 1 sine x, sine square x, right? Therefore, 0 to pi by 2 sine of 2n minus 1x upon sine x dx is equal to I1n. Clear? Therefore, Therefore, see, we had basically calculated I2n minus I2n minus 1, and it is coming out to be I1n. But see, what we had to find, we had to see option B is basically we had to find I2n plus 1 minus I2n, right? So let's replace n with n plus 1. Let's replace n with n plus 1. Therefore, I2n plus 1 minus I2n will be equal to I1n plus 1, right? I2n plus 1 minus I2n will be equal to I1n plus 1, right? So I think option B is the right choice. Option B is the right choice. Okay. Fine. Option B is the right choice. Let's move to the next question. Question number 6, which says that we have to find integration from -1 to 1 x squared plus x minus 3 dx, where this curly bracket x denotes the fractional part of x, right? Is equal to. So the hint of this question is again, see, you can write what is basically x can be written as integral part of x plus fractional part of x, right? We know this. X is basically integral part of x plus fractional part of x. Therefore, fractional part of x can be written as x minus integral part of x, right? X minus integral part of x. You can convert fractional part of x into x minus integral part of x, and after that you can easily solve the question, because see, x squared plus x minus 3 dx you can easily find by the methods of integration of polynomial, and greatest integer function of x square plus x minus 3 can also be found, right, by certain observations. Clear? So in this way you can think about this question. You have 10 seconds to solve this question. After 10 seconds we will discuss the solution. Okay, let's move to the solution part. C. Integration of -1 to 1 x square plus x minus 3 dx is basically integration of -1 to 1 x square plus x dx, right? Because see, fractional part of x plus a, fractional part of x plus a is basically fractional part of x when a is integer, right? When a is integer. Clear? Therefore, see, fractional part of x plus minus a can be written as fractional part of x only. Because see, we have added or subtracted integer only. Therefore, fractional part will not be changed, right? Just like, for example, I'm giving an example. Suppose you have an integer 2.33. So what will be the fractional part of 2.33? Fractional part of 2.33 will be 0.33, right? Now we are adding 2.33 plus 3, fractional part of 2.33 plus 3. Then 2.33 plus 3 will be 5.33. Then what will be the fractional part of 5.33? Fractional part of 5.33 will be 0.33 again, right? So by adding integers inside the fractional part will not change the value of fractional part of that fraction, right? So this thing you can remember. Therefore, fractional part of x squared plus x minus 3 can be easily written as fractional part of x squared plus x dx. Now, as we have discussed, it can be written as -1 to 1. Fractional part of x squared plus x can be written as easily x squared plus x minus greatest integer function of x squared plus x dx. So x squared plus x can be easily integrated by using integration integration of polynomial, which is equal to x cubed by 3 plus x squared by 2, and limit is from -1 to 1 minus c x squared plus x c, from where to where x squared plus x is getting giving us integer, right? So when you solve this, you'll see -1 to 0, the value of x squared plus x will be basically -1, and 0 to root 5 minus 1 by 2, because at x equal to root 5 minus 1 by 2, this thing will give you equal to give you answer. This thing x square plus x plus 1 will be equal to 1 when x is root 5 minus 1 by 2, and before that x square plus x x square plus x will be 0, right? Therefore it will be minus of -1 to 0 x square plus 1 x square plus x dx minus 0 to 0 to root 5 minus 1 by 2 x square plus x plus 1, and from from x equal to root 5 plus 1 by 2, x equal to root 5 plus 1 by 2 to 1. Greatest integer function of x square plus x will give answer as 1, right? Will give answer as 1. You have to remember this, or you have to see. This is basically the observation, right? From this limit to this limit, greatest integer function of x square plus x will give answer as 1. Clear? Therefore, we have set an interval from which the value of integer is changing. Right? From 0 to root 5, from minus 1 to 0, x square plus 1 will give answer as minus 1, right? Greatest integer function of x square plus 1 will give answer as minus 1. From 0 to root 5 minus 1 by 2, greatest integer function of x square plus x will give answer as 0. From root 5 minus 1 by 2 to 1, greatest integer function of x square plus x will give answer as 1. Therefore, we have separated these integrals in some intervals, clear, of giving answer in terms of different integers, right? Therefore, after solving this particular part, you will get 2y3 plus 1 minus 0 minus 1 into 1 minus root 5 minus 1 by 2, right? So after solving, you will get 2y3 plus root 5 minus 1 by 2, which is equal to 1 by 6. 1 by 6 into 1 plus 3 root 5, right? Answer is 1 by 6 into 1 plus 3 root 5 is the final answer. Clear? So I think option B is the right choice. Right? Therefore, answer will be 1 by 6 into 1 plus 3 root 5. So in this way, we have discussed different types of question in definite integrals. Hope in the upcoming lectures, we will discuss more types of question in the definite integrals, right? And hope you understood the lectures. You saw that these are almost similar to the indefinite integral, but some extra results we have to apply, which we have discussed in the theory portion, right? Here, so hope you understood the concepts, how to apply the concepts in the particular question. Okay, and hope you liked the lecture. Okay, thank you so much.